Hey everyone, Mrs. Garcia here. Today we are going to be finishing up this Notes 1-1 Relations and Functions. So if you remember, we left off here. So we're going to continue on from there today. So today we're going to be talking about domain and range of continuous graphs. So in part 1 of these notes, all we did was domain and range of discrete, non-continuous graphs, meaning just points on a coordinate grid, okay, just ordered pairs. Today, however, the graphs that we'll be finding domain and range for will be continuous graphs, such as a line, a curve, something like that. So that's what we're going to be doing today. And when we do domain and range today, we're going to be using what's called set builder and interval notation. So I've got some definitions here and some things that I want you to pause the video for a moment and set up real quick, because here's the deal. If you don't pause the video, and if you're trying to rush and write this down while I'm explaining, you're not going to be listening to me, you're not going to be paying attention, you're not going to understand, and then you're going to be lost and you're going to be confused and you're going to be frustrated. So go ahead and just pause that video right now, get all this stuff down so that way you can follow along with me as I go. Okay, so hopefully I'm trusting that you paused the video, and here we go. We're going to get started with the lesson today. So, like I said, today we're going to be using set and interval notation. So set uses inequalities, which hopefully, everybody in here should be familiar with one extra step. It shouldn't be so bad. So it uses braces, like so, like we did in part 1, and never uses plus or minus infinity. Interval, however, only uses numbers, so values, and it is allowed to use plus or minus infinity. And we use parentheses and brackets only with interval. So braces with set, parentheses and brackets with interval. Use a parenthesis when there's an open circle, an arrow, or a dashed line. And you use brackets when there's a closed circle or a solid line. And with interval, those values that we get, or the infinity or negative infinity, will always go in least to greatest order. And you'll notice when we're doing domain and range, we'll always look least to greatest order. Okay, so let's go ahead and get started with some of these number lines. So I'm going to start with number lines as opposed to graphs, just to kind of help you grasp the concepts before we get to the harder graphing problem. So here I started with this number line where we have shading that goes from -2 to 4, where the -2 is an open circle and the 4 is a closed circle. So hopefully, like I said, we're all very familiar with inequalities. So I'm going to define the shaded region, and I'm going to actually use the variable g, because my name is Garcia. And that's because I'm not really finding the domain and range here, so I don't need to use either x or y. When I do domain and range, of course, I'll have to use those corresponding variables. But for now, I can kind of be free to pick my own stuff, so I'm going to just pick g. So here's what we're going to do. We're going to define or represent the shaded region using inequalities. So hopefully you agree with me in that the shaded region goes from -2 to 4, where -2 should not have an or equal to. The 4 should have an or equal to, because that is a closed circle. It is included within the shaded region. Okay, and we always, with this type where we have a bound, where the shaded region is bound like this by two specific values and not an infinity but an actual value, we always use this notation where the variable lies in the middle, and we always have less than signs, never greater, not one of each or something like that. It's always less than, and then it's always least to greatest, like I was talking before, so least to greatest here. Now, if you have the or equal to or not is based on if it's a closed circle or an included piece or not. So all we have to do to make this set notation, to change it from an inequality to set, are these braces in the front and in the back. And notice in the front I left this space because we also have to do a definition kind of part. So we define the variable you're using. So g is the variable we're using, and we use this vertical line. So how you kind of read this is g such that g lies between -2 to 4, with 4 being included. Okay, so now let's talk about defining this shaded region here. So to define this shaded region that goes from 3 inclusive, including 3, to positive infinity, won't you agree with me that on the right here we're going to positive infinity? Let's talk about how that inequality will look. So let's talk about the inequality first. So I can't put a g and then less than signs and two values, because think about it, y'all, I've only got the 3. That's not a value, that's an infinity sign. And I cannot use infinity signs with set notation. So I've only got this single value here. I can't use the infinity. So I'm just going to say g something 3. Okay, what is that something? Well, hopefully you know that this shaded region here, these values are increasing. They're going 3, 4, 5, 6, 7. So you'll say G is everything greater than, and specifically greater than or equal to 3. Less than would be the other way. The values would be decreasing the other way, but in this case they're increasing, so we use the greater than sign. So again, the only thing I need to do to make this set is put the braces here, put the G such that with the braces around it. Okay, and we're done with set there. Okay, let's talk about this super special case. So this super special case is where I've got the entire number line shaded. Okay, so I go from negative infinity to positive infinity. Hopefully you agree with me that on the left, these values are getting increasingly more negative. So that's called negative infinity to positive infinity. Since I'm not allowed to use infinities in set and I don't have a value where it starts or stops, then this is a really special notation. We say G is an element, that's kind of like a C with a line through it, but it's a fancy E. G is an element of all reals. So notice I did a double-lined R. So all real numbers are being used within this shaded region. Every single number that you can think of that's a real number is within this shaded region. And then again, you need to just put your braces, your definition part, G such that, and then braces in the front. So that's set notation. Let's talk about interval notation now. So for interval notation, we're going to use values, and we are allowed to use positive and negative infinities, and we're always going to go least to greatest. So to define this shaded region here, we would say that -2 is our lowest value, comma, our greatest or highest value is 4. And what kind of symbols do I have around it? Well, -2 is an open circle, so that gets parentheses, and 4 is a closed circle, so that gets a bracket. Okay? Here, my shaded region goes from the lowest value is 3 to the highest value being positive infinity. Okay, the 3 is a closed circle, so it gets a bracket. And the infinity is an arrow, so it gets a parenthesis. Okay, here in this case, my shaded region goes from negative infinity to positive infinity, and both of those have arrows, so both get the parentheses. Okay, so now let's apply this knowledge to a word problem before we get to the graphs, just to kind of get the harder stuff over with. So, example, use both set builder and interval notation to describe the domain and range of the scenario. So here's the scenario. Grapes are on sale for $1.99 per pound with a limit of 3 pounds per customer. So you go to the store, you want to buy grapes, and they're on sale for $1.99 per pound, but you can only buy 3 pounds at most. Okay, let C of x equal 1.99x be a function that represents the cost in dollars, C of x, based on the weight of the grapes in pounds, x. So this is really nice. This problem has given you a lot of information. Okay, it makes sense that this represents the cost because you're paying $1.99 per pound. X is the amount of pounds you buy. And so that's how much it will cost whenever you buy your grapes. Okay, what's really nice about this problem too is they specifically told you that the y, or C of x, remember C of x is like y equals, the y, what you'll be using for the range will be cost in dollars. And they also told you that the x, or the domain, will be, in context of the problem, the weight of the grapes in pounds. So in my class, anytime you have a word problem like this, just so I know you know what the stuff, what everything represents and what everything is in the context of the problem, I'll always want something like this. So this isn't necessary, I'm just showing this to you to remind you. So remember from Algebra 1 that y depends on x. Y is dependent on x. Y is your dependent variable, x is your independent variable. So remember we said that C of x was our y. So cost, that's our dependent quantity, not our dependent variable. Our dependent variable is C of x. Okay, our dependent quantity is cost. Our dependent quantity's units is dollars. Notice that's in parentheses. And then our independent quantity, or our x, okay, our independent quantity is weight. Okay, our independent quantity's units is pounds. Said that there. So hopefully you understand, and it makes sense that cost depends on weight. The amount we're going to spend depends on how much weight we buy. Yes, cost depends on weight. So every time you have a word problem, I need to see this so I know you know what's the y and what's the x. Okay, what's the dependent quantity and what's the independent quantity. Okay, so now let's talk about finding the interval in set notation. All right, so domain, let's talk domain. So again, domain is our x. Okay, so that's our weight. So remember, least to greatest. What is the least amount of weight of grapes that you can buy? Can you not go to the store and buy 0 pounds? Yes, you can. You can go to the store and buy something totally different than grapes. You can buy a water bottle. So the least amount of grapes we can buy is 0, and that gets a bracket because that's an included value. I can buy exactly 0 pounds, comma. What's the greatest amount of grapes I can buy? Well, based on this problem, the greatest amount of grapes I can buy is 3 pounds per customer. So that would be 3. The greatest amount of weight I can buy is 3 pounds. Okay, so that's interval. How do I write that in set? Well, since I have two values, since it's bound like it was here, I'm going to do my x, now that I'm doing domain, such that the x lies between these two less than signs. My two values go around it with my braces, and they both get or equal to, because I can get exactly 0 pounds or exactly 3 pounds. Those are included values in my domain. Okay, so next let's do the range. So range, remember, is your y or your cost in this situation. So what's the lowest cost that you will spend? Okay, and of course if you buy 0 pounds, the lowest cost that you'll have is $0. Okay, that's the least you can spend on grapes is $0. What's the most you can spend? Well, that's a good question, isn't it? Well, if I can buy at most 3 pounds, then how much would that cost? Well, let's calculate that. So C of 3, if I can buy 3 pounds, what's $1.99? Plug in 3 where you see X. What is that value? So C of 3, our cost for 3 pounds, that's what that means, our cost for 3 pounds. And think of that like round up to $2. And $2 times 3 would be 6, but then remember you added 1. And you really added 1 3 times. You added 1 penny 3 times. So take those 3 pennies away from $6, and that would be $5.97. Okay, so $5.97 is the most that you will spend if you buy the most amount, which is 3 pounds. So then our range in set notation is going to look very, very similar to up here. We've got the y in between, the less than or equal to signs, our low value and our high value, our min and our max values here, and then our braces around. And remember, these are always less than signs. They may or may not have the or equal to, but they're always less than signs. Okay, let's finally get to the graphs. So here we go. All right, so find the domain and range of each graph in set builder and interval notation and determine if it is a function. Okay, so domain first. Remember, for domain, we're looking at x. The x-axis runs left to right. We want least to greatest. The values are least on the left side. They're negative on this side. They're greatest on the right side. So we read left to right. And I usually use a highlighter to kind of show me what those bounds are. So on the left, the leftmost point on this graph, the leftmost point is this point here. It doesn't go any more left than that. That's an open circle, so I'm going to use a dashed line for that boundary. Notice it cuts through the x-axis. That's what it's supposed to do because we're talking domain. We're talking x. This is my rightmost, so remember left to right, this is my rightmost bound. This is the furthest right this graph goes. And when I draw it to cut through the x-axis here at 3, I think it does, I'm going to draw a solid line because that is a solid circle. So then I just need to find where those points are on the x-axis, and that's what I'm going to use for my values. So here I'm going to define x such that, and since I have two values, that means the x lies in the middle with the two values on the outside. So here this smaller value is -2, and this higher value is 3. And then this one gets a or equal to because it's a solid line. Okay, the interval notation will use the same values, obviously. The graph goes from -2 to 3. On the x-axis, the -2 gets a parenthesis because that's a dashed line, and it gets a bracket here because that's a solid line. Okay, so then range. Range. So range is y. The y-axis runs up and down. Okay, with my lower numbers at the bottom, my higher numbers at the top. So I read the graph bottom to top. How low does the graph go, right? So I read bottom to top. This is the lowest point on the graph, yes? Okay, and I'm going to use A dashed line because that's an open circle. This is my highest point on the graph, and I'm going to use a solid line because it's a closed circle. Okay, and where do those cut through the y-axis? Because I'm talking about range. So this cuts through the y-axis at -1, -2, -3, -4, -5. So of course I'm going to define y. Have the y here and my less than signs around. So -5, and I have no or equal to, and then the +5 has the or equal to because it's a solid line. Okay, and for interval notation, -5 to 5, I get the dashed line has parentheses, the solid line up here has a bracket. And it did say and determine if it's a function. This certainly passes my vertical line test. This is a function. Okay, we're going to just do odds here for sake of time. So number 3. On number 3, domain. So let's talk domain. Remember, domain is x. The x-axis runs left to right if we're going least to greatest. So left to right here, how far left does this graph go? Right here, and it's a solid line because it's a dot. How far right does this graph go? Well, that's a great question. This arrow is going right forever. I can't say, oh, that's where it stops, because it doesn't. It goes forever. So this is one of those situations where, like earlier, that you only have one value to put. So that means I'm going to do my x such that, and now the x goes in front because it doesn't have two values to surround it. It only has this single value. So what is that x value on the x-axis? That's -1, -2, -3, -4. Remember, leave your space, close your brace. Okay, and what do we put here? Well, as I follow this graph along and go in the direction of the arrow, what's happening to my x values as I go to the right? Remember, I'm going to the right. My x values are increasing, so you'd say greater. And specifically greater or equal because that's a solid line in a closed circle. How does that look for interval notation? So remember, interval notation is least to greatest. So on the left, the leftmost value is -4, and that gets a bracket because it's a solid line. Okay, and our rightmost value, think about it. What are we going to on the right? On the right, x is going to positive infinity. And since that has an arrow on the right, we get parenthesis. Okay, so for range, remember, bottom to top. Bottom, how low does this graph go? This is the lowest point on the graph, right here. Wouldn't you agree? It doesn't go any lower than that. That's the lowest point on the graph. Can I say, oh, don't be fooled. Can I say that's the highest point? Well, no, I can't, because that arrow is going to keep going higher and higher and higher. So just like the domain with the range, I don't have a topmost value. So again, since I've only got the one value, I've got to do y such that y something, and then where am I crossing through the y-axis? I'm crossing through the y-axis at 0. And what am I going to put here? Well, as this arrow goes up, the y values are increasing. So I say greater than. And notice I did draw a solid line, and it's going to be or equal to because my graph strikes at 0, at y equals 0. So I do have a solid line there because it does strike at 0. So we have or equal to. Okay, for interval notation, again, remember bottom to top. How low, how high? How low does the graph go? The lowest y value is 0. It gets that bracket because it is touching there. Comma, how high does it go? Well, hopefully you'll agree with me that this goes to positive infinity. And since there's an arrow at the end for that positive infinity, infinities, if you haven't already noticed, always get parentheses. And is this graph a function? Why, yes, it certainly is. Okay, number 5. Domain. Okay, left to right. Left to right. On the left, how far left does this graph go? How far left? Well, actually, I know it's going down, but isn't it also going left forever? Yeah, it is. It's going left forever. How far right does the graph go? Well, it does stop right here. That's as far right as it goes. And again, it's a solid line because it's a closed circle. Okay, so again, I only have one value, one place where I drew a line that cuts through the x-axis. So since I only have that one value and not two, I can't put the x in the middle with two values. I have to do the x such that x something, and what is that x value? 1, 2, 3, 4? 4, and what am I going to say? What is that something? As this graph goes, I know it's going down, but y'all, we're not talking about y's right now. We're talking about domain. We're talking about x. So when we're talking x, is the graph going left or is it going right? Ah, it's going left. So as I go left, my x values are decreasing. So you'll say less than, specifically less than or equal to, because that's a closed circle there. Okay, for interval notation, again, left to right. I can't reiterate that enough. On the left, how far left does this graph go? Well, it's going to go forever. I can't say there's a specific value it stops at on the left. It's going to go forever. And hopefully you agree with me on the left that my x values go to negative infinity. And on the right, how far right does it go? Well, we already said positive 4. And again, on the left, we've got that infinity. It's going forever. That's an arrow. And on the right, a closed circle, so that's a bracket. Okay, so for range, I'm looking bottom to top. So how low does this graph go? Well, I can't bound it because it goes forever. How high does this graph go? Well, that's as high as it goes. And again, it strikes, the graph strikes at exactly 1, 2, 3, 4 here of the y value of 4. So I am going to put a solid line. That's not an open circle there. It does hit. Okay, so that's a solid line. So we're going to say, since we only have one value, y such that y something, what's that value? It's 1, 2, 3, 4 on the y-axis. Remember, I'm doing range, so we're only talking y-axis. And then what's happening to my y values as this graph goes down and down and down? They're decreasing. And again, that's a solid line. You would put or equal to. And then here on the range, remember, for interval notation, bottom to top, how low, what's the lowest, and what's the highest? The lowest, hopefully you'll agree with me, it's going down to negative infinity, and how high is positive 4. The positive 4 is solid, so it gets that bracket. Infinity and negative infinity, because they're represented by arrows, always get parentheses. Is this a function? Hopefully you'll agree with me. Yes, it sure is. So this is a function. Okay, last thing. Let's hurry on up. Okay, an asymptote is a line that a graph approaches as x or y increases. So an asymptote is distinguished by this dashed line here. So this dashed line is an asymptote. This dashed line is an asymptote. So for now, in your knowledge in Algebra 2, we will say that an asymptote is a line that the graph itself, will never cross, never touch. In pre-cal, we'll talk more deeply about that. But for now, we'll say the asymptote is a line that the graph will never cross or never touch, okay? So what that means is this graph here, although it looks like it's touching because my pixels aren't great on a computer or whenever it prints out, it's getting as close as it possibly can, and every time we go more and more left, it's getting closer and closer to that line, but it actually never touches it. If you could zoom in, you would see it's microscopically close, but it's not touching. Okay, so we're going to find the domain and range of each graph in set builder and interval, and then we're going to determine if the graph is a function. So first let's do domain and set. So remember, domain is left to right. I will ingrain that in your head a million times. Left to right. So can I say, oh, that's where the graph starts on the left? That's how far left it goes? No, because it's going to go forever. On the right, can I say, oh, that's how far right it goes? No, because it goes on forever. There's nowhere I can draw a line and say, oh, that's it. That's as far as it goes. That's as far as it goes. I have absolutely no lines on my graph. Okay, that's unlike anything I've ever done so far, except in the front. Remember in that front page when we first talked about this, we said that funky thing, x such that x is an element of all reals. So remember, x such that x is an element of all real numbers, means it goes forever, it has no bounds. Okay, so how that will look for interval notation is we'll say on the left, we're going to negative infinity, and on the right, the x's are going to positive infinity, yes? Okay, for the range, when we read bottom to top, how low does this graph go? Well, with a dashed line, we will distinguish that this point here at y equals -1 is as low as it can go, because remember I told you we can't cross, we can't touch. We'll get as microscopically close as we can, but we'll never cross, never touch. So I do have that low boundary, but I don't have a high boundary because it's going to go forever. So you're going to say y such that y something -1, and that something is greater than, not greater than or equal to, that's why I drew a dashed line, because we won't touch, and that's why that asymptote is a dashed line. You won't touch it. Okay, so y such that y is greater than -1, because my y values are increasing as I go up. Okay, how that'll look on the interval notation is the lowest value is -1, and again that gets parentheses because that's a dashed line, and my highest value is infinity because I go up to positive infinity, and with that arrow I always get parentheses. So is this a function? Why, certainly, it sure is. And we're right under 25 minutes.